In this video, we're going to go over 5.2 probability rules. We're going to review probability model, talk about the main 5 basic probability rules. Then we're going to go over some diagrams, some notation with probability. So first, you're going to be able to describe a probability model for a chance process. First, a probability model has 2 parts. The first part is a sample space S. The capital S here will be sample space. This is a list of possible outcomes. It's a very simple list. All the possible outcomes in a given situation. So the probability model has 2 parts. One of them is the sample space. So that is the first part. The second part is the probability for each outcome, or for each event. So the second part would be probability for each outcome included with the sample space. Those 2 entities make up the probability model. What we call an event is any collection of outcomes from a chance process it's a subset of S. Remember, S stands for our sample space. So it's a smaller grouping of S. It could be just one item or one outcome, or it could be multiple items. So a probability model for rolling a die. Your sample space for rolling a die, you have 6 options, or 6 outcomes. And so that would be part 1. Part 2, the probability of each outcome. Every outcome is the same. They're all 1/6. So each outcome has a probability of 1/6. So those are 2 basic parts for your model. Mention the sample space, and then mention the outcome, or the probability for each outcome underneath. All right, so probability has 5 basic rules. We're going to review those right now. First of all, probability is defined by being between 0 and 1, inclusive. So probability is always 0 less than or equal to p less than or equal to 1. It can be 0 and 1 and anything in between. It cannot be outside those parameters. If your probability is 0, that means it's never happening, or it never happens. If probability is 1, it always happens, or is guaranteed to happen. That's rule number 1. Rule number 2 is all possible outcomes must add up to 1, or 100%. All possible outcomes must add up to 1. And this makes sense because something must occur. One of the outcomes, it has to occur. You can't leave anything open. So if all your outcomes add up to 0.8, that means 0.2 is missing somewhere. You need to include that in your sample space. Number 3, if all outcomes are equally likely, all outcomes are equally likely, then we can define probability of A as the number of outcomes corresponding to A divided by total outcomes in the sample space, or an S. So that's your probability of A happening. Number of outcomes corresponding to A, or event A, and then total outcomes in S. For probability that an event doesn't occur is going to be 1 minus the probability that the event does occur. This is called the complement. And there's two different notations you can use for this. So if event A is written as just capital A, the complement of A can be written as A with an apostrophe or A prime, also known as. Or you can write it with A and then a C for complement. This means not A. So if A is flipping a heads, then not A is flipping a tails, because that's the only other thing in the sample space for flipping a coin. And then lastly, rule number 5 is if two events have no outcomes in common, they don't share any outcomes, then the probability that one or the other occurs is the sum of their individual probabilities. So the probability that one or the other occurs is the sum of their individual probabilities. So this is the A or B, so the probability of A or B happening. If they are sharing no mutual outcomes, just probability of A plus the probability of B. That's rule number 5. So that's the addition rule for mutually exclusive events, which we're going to describe right here. Complement rule is number 4, and the 3 basic ones above. Mutually exclusive, also called disjoint. It's two events. They are mutually exclusive when, or if, they have no common or no outcomes in common and can never occur together. It's impossible for them to happen at the same time. So for example, if you're drawing from a deck of cards, you cannot draw a card that is a face card and a 2, because they can't have it at the same time. Face cards are face cards. A 2 is not a face card, so therefore it cannot have an intersection or can't happen at the same time. So those would be mutually exclusive events. It just means the two events that don't ever occur together. So the probability of A and B happening here would be 0. It's impossible. Remember that from up here? Probability of 0 means that it can't happen or never happens. Okay. So we have table with an example here. Some probabilities to work through. It says Canada has 2 official languages, English and French. Choose a Canadian at random and ask, what is your mother tongue? Here is a distribution of responses combining many separate languages from the broad Asia-Pacific region. So, language, English, French, Asia-Pacific, or other. We have probabilities of 0.63, 0.22, 0.06, and a question mark. That's part A. What probability should replace the question mark in the distribution, and why? Well, if we know from rule number 2, rule number 2 states that it's got to be a sum of 1, because something has to happen here. So what you're going to do is you're going to take 1 and subtract all the known probabilities, 0.63, 0.22, 0.06, and when you do that, you get 0.09. And the reason why is because all of these must sum to the 1, a probability of 1, because something's going to happen. Part B, what is the probability that Canadian's mother tongue is not English? Not English is a complement. Okay, so you could write this as probability of English with a little prime there, or you could write probability English and then a little C up top. You do 1 minus the event's probability. So 0.63. 0.37 is the probability the mother tongue is not English. Part C, what is the probability that Canadian's mother tongue is a language other than English or French? So other than or not, it's a complement of an or statement. So English or French. So other than, we're going to call the complement of English or French. This is going to be 1 minus the sum of these two. Okay, so we talked about the mutually exclusive events. If you have English or French, the probability of that happening is these two right here added together because they are mutually exclusive. I'm doing 1 minus because I want to find not English or French. And when you do that, you get 0.15. So the probability that mother tongue is a language other than English or French is 0.15, or 15%, you could say. Okay, so what if we have two events that are not mutually exclusive? We want to find out the addition rule for it. Well, there's one extra thing you got to add in there. So if you have A or B, and A and B are not mutually exclusive, the first part of the equation is the same. But in order to prevent double counting, we have to do one more subtraction. And that's the probability of A and B happening. We'll show why in a two-way table, why you have to do this part right here. Because otherwise you actually double count the probabilities. There's also a notation that you should know is the OR symbol is the union, little u. So that means A or B. And then for and, you just flip it around. So looks like a little n. That's the intersection of the two events, probabilities. So either way you write it, it's the same thing. On an equation sheet, you're going to see this, but realize that this means or and this means and. All right, so Venn diagrams. Just to try to show you what these look like. You have the event A. Everything that's not an A is also shaded here. This is the complement of A. This one event. So everything that's A is inside the circle, everything that's not A is outside the circle. That's the A with a little C right there. These two events, event A and event B, there is no intersection whatsoever. These don't touch at all. There's a gap here. These are mutually exclusive. Or we call them disjoint. Those two things mean the same thing. So if you see two circles like that, mutually exclusive or disjoint, if they were to overlap, that changes things. Now you don't have mutually exclusive events anymore. This picture here, you have two circles that intersect. They're just highlighting this piece right here. That's A and B occurring. So I'll write that a little bit bigger. A and B. So the overlap of the circles, that's both in A and B. So if we were to cut this off, that dark circle's in A. It's also in B, which is why it's A and B in the middle there. The second one, or sorry, this right real quick, called the intersection. The second one's called the union. It's everything in A and everything in B, including the A and B. So we call that A or B. So anywhere in this darkened area is A or B. It could be A, just B, or both A and B. That's what the union is called. And that symbol is like a U in between the two event letters. Okay, let's actually use this these rules in a situation. In an apartment complex, 40% of the residents read USA Today. Only 25% read the New York Times. 5% of the residents read both papers. Suppose we select a resident of the apartment complex at random and record which of the two papers the person reads. First, make a two-way table that displays the sample space for this chance process. Two-way table. One variable is USA Today. The other is New York Times. It's a simple yes or no question. Yes, no. And then yes, no. Okay. So the two-way table, for probabilities at least, bottom right corner, the total of the totals will be 100%. Okay? First statement, 40% of the residents read USA Today. Only 25% read the New York Times. So of the residents that read 40% read USA Today. So USA Today, yes, 40%. No, or the complement of that would be 60%. These two must add up to 100. 25% read the New York Times. Over the yes, 25%. No, 75%. So if we don't have one of these squares, we have none of these squares. But luckily they gave us this little number here. 5% of the residents read both papers. Yes, yes, that's 5 right there. And across this column, these two must add up to 40. These two must add up to 25. So this is going to be 20% here for a yes, New York Times, no USA Today. 35% for yes, USA, and no New York Times. And you take either one of these subtraction problems. 60 minus 20 here is 40%. So it's 40% for no for both. All right. Part B, construct a Venn diagram to represent the outcomes of the chance process. So a Venn diagram, simply just draw this. Two circles. So we'll call this A, this B. We'll make A the USA Today, B New York Times. So the percentages look like this: 35%, 5%, 20%. The 5% was given to us. These two numbers were not, but you'll notice they appear right here. You're going to want to say A, USA Today. That should be 40%, right here. The problem is the entire circle has to be 40%. So just A is 35, and then with this piece that overlaps, 35 and 5 make 40. If you look over here as well, the New York Times should be 25. Just the New York Times is 20, and then the entire New York Times with the overlap is 25. And then outside of the complement of these two is 40%, given from the table right here. So we got part A done, we got part B done. Part C says, find the probability that the person reads at least one of the two papers. So probability at least one of the two papers, that's going to be A or B, because it could be one or the other or both. So since these two events are not mutually exclusive, we have to use this formula. Let's talk about why we have to subtract the probability of A and B. If you were to add the probability of A and the probability of B, so that would be 40 plus 25. If you add those two numbers together, you get 65. Okay? The problem is you're counting 5 twice. You think about it. 25% plus 40%, I just used the 5 twice. So what you're going to do is you're going to subtract that middle piece where the circles overlap, or right here, the yes, yes. You're going to need to subtract that to find A or B. So probability A or B, so we're going to use probability of A, which is going to be 40%. Probability of B is going to be 25%. And then we're going to subtract that middle piece where the circles overlap, 5%. And when you do that, you're going to get 60%. So 60% chance that a person reads either USA or New York Times. So 60% chance that a person reads either the USA or New York Times. It could be both. You have to include that with the union of the two events. Okay. Part D says, find the probability that a person does not read or doesn't read either paper. That's a complement to the previous problem. So what you're doing here is you're finding the probability of essentially not this, okay? So the probability of not A or B. So probability of not A or B, we know what A or B is. The complement of 60%, it's a pretty simple equation. It's 100% minus 60%, and you get 40%. So the probability you get someone that doesn't read either paper is 40%. Another way of thinking about it is, this is also the probability of not A and not B. It means the same thing. If you look over here on our table, no and no, that spot there is 40% of the amount of people that live here that don't read either paper. You should get the same number from the table or from your math. Okay? Lots of different ways you can actually arrive at that answer, but what's most important is that you get these two numbers to add up to 100%. So if I ask you for one event and ask for the complement, you should have those two numbers add up to 100%. This may look like a lot of equations being thrown at you, but this basic one and all the other basic ones will be given to you. You just have to know how to use them. Mainly, do you understand that union means or and intersection means and? Those are very important distinctions. So not only be able to write it with and or the word, but the actual notation, with the N or the U. Okay, so we talked about the basic probability rules. We talked about the probability model, what's included in it. 5 basic rules again, between 0 and 1. 0, never happening. 1, always happens. All the possible outcomes must add up to 1. If the outcomes are equally likely, then this is your probability statement. So number of outcomes corresponding to A divided by total number of outcomes in S. 4, this is your complement rule. So the probability the event doesn't occur is 1 minus the probability that the event does occur. We use 2 different notations for that. You can use the little apostrophe or the little c. It means not A. So you can read that, you don't have to say A apostrophe or AC, you just say not A. Or complement of A is also appropriate. If 2 events have no outcomes in common, then the probability that one or the other occurs is the sum of the individual probabilities. So P of A or B is just P of A plus P of B. Now, if this doesn't occur, if you have mutually exclusive events, 2 events that aren't mutually exclusive. So if they are not mutually exclusive, this is what you do, okay? And this equation is actually more specific than the one in the front. If you think about it, general addition rule for 2 events, if my 2 events are mutually exclusive, probability of A and B happening is 0. So when you subtract 0, that becomes the equation in the front.